class. This is Mr. Adewale, your teacher. We are in today for physics, and today we are considering density and upthrust. Density and upthrust. What is density? Density is a substance. The density of a substance is its mass per unit volume. Density is simply mass over volume. The mass of a substance divided by the volume of the substance, that is density. We'll be talking about upthrust. Upthrust is just talking about the weight displaced. The weight displaced. The weight of substance displaced. That's upthrust. And that was gotten from law of flotation. Now, let's talk about relative density. What is relative density? We have some definitions for that. That's the density of substance over the density of water. Relative density is the density of substance over density of water. It's also the mass of substance over mass of equal volume of water. Mass of equal volume of water. Again, relative density is the weight of substance over weight of equal volume of water. And the same thing as upthrust in liquid. That means it's talking about the weight displaced, the weight of substance displaced in liquid all over the weight of substance displaced in water. Upthrust means weight displaced. So the weight of substance displaced in liquid over the weight of substance displaced in water. And again, we have let's note this. Relative density has no units. And again, the density of water is 1 gram per centimeter cube or 1,000 gram per meter cube. So all this, there are two laws so all these density and upthrust, they are anchored on two laws: the law of flotation and Archimedes' principle. So let's really talk about Archimedes' principle. State that when a body is wholly or partially immersed in a fluid, it experiences an upthrust, which is equal to the weight of fluid displaced. When a body is wholly or partially immersed in a fluid, it experiences an upthrust, which is equal to the weight of fluid displaced. So, and the law of flotation says a floating body displaces its own weight on the fluid on which it flows. A floating body displaces its own weight on the fluid on which it floats. So, those are the two laws upon which this topic is anchored. Now we're going to consider some questions together, considering all these formulas. So let's go and check the questions together and solve them together. Can we do that now? Right, the first question is to convert 0.2 gram per cm cube to SI, that's standard international unit. You have to convert to the standard. You can see gram must be taken to the standard form, that's kilogram, and then the standard units for length and distances, that is meter, not centimeter. So we change it to standard form. The second one, an empty relative density bottle weighs 25 grams. It weighs 65 grams when filled with a liquid and 75 grams when filled with water. We have to calculate the density of the liquid. An empty relative density bottle weighs 25 grams. That's the weight in air of the empty bottle. It weighs 65 grams when filled with a liquid and 75 grams when filled with water. Then we have to calculate the density of liquid. And the third one, a solid weighs 10 Newton in air. A solid weighs 10 Newton in air, 6 Newton when fully immersed in water, and 7 Newton when fully immersed in a certain liquid X. Then we have to calculate the relative density of the liquid. We have to calculate the relative density of the liquid. And the fourth one, if 32 grams of kerosene of density 0.8 grams per cm cube are mixed with 8 grams of water, what is the density of the resulting mixture? What is the density of the resulting mixture? So quickly consider this together now. The first one now, we have to convert 0.2 gram per cm cube to SI units to SI units. So how do we do that? That's 0.2 gram all over cm cube, and we know that 1 gram will be 1 over 1000 kilogram, and that's 10 raised to power minus 3 kilogram. You know that? And again, 1 cm cube will be 1 over 100 meters. So, and that's 10 raised to power. So, and this is 10 raised to power minus 2 meters. So let's impute that. That will be 0.2 gram over cm cube will be 0.2 multiplied by the kilogram, and that's 10 raised to power minus 3 kilogram. Now this is kilogram now, all over cm. 1 cm will be 10 raised to power minus 2, but raised to power 3 now. 1 cm is this, raised to power 3 now will be raised to power 3, and this is now meter cube. I hope it's clear to you. 1 centimeter is 10 raised to power minus 2 meters, but cube now. Okay, so that's why we have meter cube too. So this will be 2 multiplied by 10 raised to power minus 1 is multiplied by 10 raised to power minus 3 all over this 10 raised to power minus 6, and this invariably will be 2 multiplied by 10 raised to power minus 1 minus 3. When this one comes up, the sign changes. That's minus 6. Then will be 2 multiplied by 10 raised to power minus 4 plus 6 minus 4 plus 6. Are we together? And this will be 2 multiplied by 10 raised to power 2. So then the unit is now kilogram per meter cube. Kilogram per meter cube. So you can change it to 200 kilogram per meter cube. I hope this is clear. Can go through it again. Thank you. So the second question now, an empty relative density bottle weighs 25 grams. The empty bottle now, the empty bottle weighs 25 grams when filled with liquid. That's bottle with liquid weighs 65 grams. Are you following? And when filled with water, the bottle with water now, that's 75 grams. So we have to calculate the density of the bottle. So we recollect that, okay, one of the formulas. So we have to calculate the density of the liquid. One of the formulas we are given at that time, relative density is what? That's the weight of substance. The weight of substance all over weight of equal volume of water. Now, the weight of the substance. Now, the substance here of weight of the substance. We're talking of a liquid now. It's a liquid now. Now, the weight of the substance now. We have the weight of the empty bottle and that of the liquid. So that will be the weight of the substance. That's 65 minus 25 grams. The weight of substance, the weight of the substance, the empty bottle, when you have the bottle with liquid now, when you subtract the empty bottle from it, then you get the weight of the substance of the liquid. The bottle with liquid is 65, the empty bottle is 25. By the time you subtract it from that of the liquid from that of the empty bottle from the liquid, you get the weight of the substance all over the weight of equal volume of water. Now the weight of equal volume of water, that's talking of the upthrust in the water, the weight displaced in water, and that will be the weight displaced in water, that's 75, that's in water, minus 25, the weight of equal volume of water. By the time you bottle with water, you subtract the empty bottle from it, you get the weight of equal volume of water. I hope that is clear. And so this is 40 all over 50, and invariably that is 4 over 5, which is 0.8. 0.8, that's the relative density, but that's not the answer. We are asked to calculate the density of the liquid, but we have the relative density now. Again, we know that relative density is what? Density of substance. Density of substance all over density of water. So and you have relative density to be 0.8, to be the density of substance, all over density of water has been given the other time to be 1000 kilogram per meter cube. That's density of water. Therefore, the density of the substance, which is the liquid in this case now, the substance we are considering, will now be 0.8 multiplied by 1000 kilogram per meter cube. And that's 800 kilogram per meter cube. That is the density of the liquid that we are asked to calculate. I hope that is clear. That's the density of the liquid. So once again, let's go through it. The relative density. Now we are given the weight of the empty bottle and the weight of the bottle with liquid and that of bottle with water. Now, so the first thing now is so the first thing to get the density of substance, the first thing, let's get the relative density now, and that's weight of substance over weight of equal volume of water. To get the weight of substance, you subtract weight of empty bottle from that of bottle and liquid, then you get the weight of the liquid. Then to get the weight of equal volume of water, subtract the weight of empty bottle from that of bottle and water. So we have got the weight of equal volume of water, and so from there we got the relative density. Then we know the formula relative density equals density of substance over density of water. Then and we have got this to be 0.8, and density of water is what? 1000 kilogram per meter cube. From there you cross multiply, then you get the density of the substance. I hope that is clear. The third question now. The third question. The solid weighs 10 Newton in air. So the weight in air is 10 Newton. That's 10 Newton. The weight when fully immersed. The weight when fully immersed in water. Weight in water. Now is 6 Newton. You will notice that there is a weight that's been displaced. That's the upthrust. There's a weight that's been displaced. That's the upthrust. That's weight displaced. The weight displaced. Alright? And weight when fully immersed in a liquid. Weight in liquid X. That's what? 7 Newton. I hope you are getting that. Then we are asked to calculate the relative density of the liquid. Alright? Which of the formulas will be applicable now? Now, this will be weight displaced in liquid over weight displaced in water. That's upthrust. Upthrust in liquid. That's weight displaced in liquid over upthrust. Upthrust, I've told us, upthrust is the weight displaced in water, in equal volume of water. And when we talk about Upthrust, you will notice that when you put a drawer into a well, when the drawer is inside the well and you are trying to draw it, it looks like that thing is light because there is a weight displaced. The weight of something is displaced when in water until when you take it outside the water, then you know it's heavy. So that's talking of Upthrust, the weight displaced. All right, the weight displaced in liquid will be, that's the weight in air minus the weight in liquid, that's 7 all over Upthrust in water, the weight in air, the actual weight minus the weight in water, and this will be 3 all over 4. That's the relative density, and invariably relative density will be 0.75. That's the relative density. I hope that is clear. God bless you. The last question here, that's number 4. If 32 grams of kerosene, that's the mass of kerosene of density 0.8 gram per cm cube. Mass of kerosene is 0, that's 32 grams. 32 grams, that's the mass of kerosene. The density of kerosene given, that's 0.80 gram per cm cube. You have to consider the units. It said if they are mixed with 8 grams of water, the mass of water, H2O, mass of water is 8 grams. It said what's the density of the resulting mixture when they are mixed together? Again, you should remember that the density of water is 1 gram per cm cube. That's a constant. And so it was not given because you are expected to have mastered and known that density of water. And you have to calculate the density of the resulting mixture. Before we can do that, and we know that density is what? Mass all over volume. Density is mass over volume. We actually have the masses, but we don't have the volume, so we have to calculate the volume. All right, volume of kerosene. The volume of kerosene will be the mass of kerosene all over the density of kerosene. And what's the mass of kerosene given? The mass of kerosene is 32 grams, and the density of kerosene is 0.8 gram per cm cube. Now, then we proceed from there. Invariably, if you check this now, so the volume is 40 cm cube. 40 cm cube. Now, volume of water will be mass of water all over density of water. Density of water. And what's the mass of water given? That's 8 grams. The density of water is 1 gram per cm cube. Now you don't change to kilogram because you can see we have been dealing with grams and cm cube. So, alright, that's 8 cm cube. That's the volume. So total volume will be 40 cm cube plus 8 cm cube. That's 48 cm cube. That's total volume. Total mass. The total mass will be, has been given, 32 grams plus 8 grams. And that's 40 grams. That's total mass. So the result in the total density will be total mass all over total volume. So what's the total mass? That's 40 grams all over 48 cm cube, and that will be 0.83 grams per cm cube, or 830 kilogram per meter cube. So this is the volume of the resulting mixture. I hope this is clear. I hope this is clear. Go through it again, check it. God bless you. Thank you. Right now, I'm going to give some questions now. You will do well to attempt them, solve them, and leave your answer in the comment section. And if you are seeing coming through this coming to this you are seeing this channel for the first time, do well to subscribe. Click press the notification button, share with your friends, and pass your comments. God bless you. Thank you. So these are the questions now. Number 1. A solid weighs 45 Newton and 15 Newton respectively in air and water. Determine the relative density of the solid. Number 2. A solid of weight 0.6 Newton is totally immersed in oil and water respectively. If the upthrust in oil is 0.210 Newton and the relative density of oil is 0.875, find the upthrust in water. The third one, an object weighs 10 Newton in air, 7 Newton when immersed totally in water, and 7.6 Newton when immersed in a liquid. Calculate the relative density of the liquid. So these are the questions. Attempt them and leave your answer in the comment section. God bless you. Thank you.